Hello, sophomores. I hope you guys are doing well today. Today we're going to do a little mini lesson on writing a two-column proof. We're going to do two examples together. I'm gonna lead us through two examples, and then I'm going to have a third example that I want you to do in your notes, and I want you to try it on your own. When you try this, hopefully you'll find it successful. If not, it's still worth trying and learning from. So I just want you to try your best on example 3. For your planner today, I want you to submit these notes. I want you to take notes on this video in your notebook, take a picture of those notes, and submit them to Canvas by 3 p.m. today. This is how you'll get your attendance credit for showing up today, by submitting these notes and trying that third problem. Okay, so again, today we're writing two-column proofs. To prove something in math, is a tall task. It's a lot to ask. So what we're going to do today is we're going to look at some kind of simple basic examples of this to get the hang of writing it, and we'll move on as we continue to do this to more challenging proofs along the way. Okay, so let's move to the next slide. Here's example 1. I'm just going to go ahead and have you pause the video right now, and I want you to sketch that sketch and write the given, the prove, and make your two columns with statements and reasons. So go ahead and pause the video right now. Okay, so here we have our picture. I see a picture with two triangles next to each other there. There's no markings on there, but there is a given line. So what's given here, again, we need to know our notation. We have notes from that from the very beginning of the school year, so if you're ever confused on your notation, just look back in your notes. But if you look here at this given, it says given AB, segment AB is congruent to segment AD. This is the given information in a proof is stuff that we know to be true. That's just given to us by the problem writer. In this case, the problem writer is me. So we know that AB and AD are congruent to each other. Those two sides, those two segments here are going to be congruent to each other. We also know that BC and DC are congruent to each other. This is kind of like what we practiced on Wednesday in class. Okay, so we're going to be given some information, and we're going to be asked to prove something. We know we're done when we can prove what's being asked of us to be proved. Okay, if we take a look, the notation here is for us to prove. Notice that little symbol there. We're trying to prove triangle ACB is congruent to triangle ACD. So I'm trying to prove that these two triangles are congruent to each other. I'm going to do this by making some statements. This is kind of like when you're writing an essay in English class. You're going to make a claim. But every time you make a claim, you have to give evidence for that claim, why you know it's true. Same thing here, right? I can just claim, hey, these two sides are equal, these two angles are congruent. I can claim those things, but I always have to have a reason for why it's true. Okay? This is exactly what we've been practicing, but we've been building up to. Okay? So a good place to start on writing this two-column proof is oftentimes I like to start by stating what's given, right? Even though it's given to us, it needs to show up in our two-column proof. So my first statement here is going to be that segment AB is congruent to segment AD. So I'm going to make that statement. Anytime I make a statement, I better have a good reason for why I know it's true. The reason here is pretty obvious. I know that segment AB and segment AD are congruent to each other because that was given to me. So that's my reason. My reason is just, it was given. All I have to do is write the word given. What I also want to do right now is every time I make a statement that I'm able to have a reason to prove it, I want to annotate my picture with that given or with that statement that I made. So My statement was that segment AB and segment AD are congruent. I want to annotate that in the picture right to the left there. Okay, this is a step that doesn't necessarily have to be done to get full credit on the proof, but students who annotate their pictures are much more likely to have perfect proofs. So let's go ahead and mark, right? We're talking about segments here. So I want to mark segment AB right there is congruent to segment AD right there. So as you are writing your proof, as you're making your statements, make sure you are annotating your picture to reflect that. Take a guess right now. What do you think my statement 2 is going to be? If you thought my statement 2 will be that segment BC is congruent to segment DC, you are correct. That's my other given piece of information, so I want to state that as well. What do you think my reason would be how I know BC and DC are congruent? Well, again, for the same reason as my first statement, I know that BC and DC are congruent because it was given to me. So I'm going to write my reason as given. And then I'm also going to mark my diagram. Now, since I used a one tick mark on segments AB and AD, I'm going to use a 2 tick mark on BC and DC. Now, unfortunately, I am out of given statements. Nothing else has been given to me. So I want to take a look at what am I asked to prove? I'm asking you to prove that triangle ACB is congruent to triangle ACD. Well, I know from class earlier this week, I know that triangles are congruent if I can reach one of those 5 postulates, either SSS, SAS, ASA, AAS, OS, right, or HL. Right now I have SS. That's not enough to prove it. But again, hopefully you're seeing what maybe my next statement would be, right? Hopefully you noticed, hey, look at AC right there. AC is a shared side between these 2 triangles. When we had that on the homework previously, we've marked that thing congruent to itself. So that's going to be my next statement. And it's kind of weird saying something is congruent to itself, but let's mark it. By the way, if you said CA is congruent to CA, that's also correct. It doesn't matter the order here if you call it AC or CA. Okay, so I'll mark that AC congruent to AC. I'll just mark the AC with a 3 marker. And now here's the question to see if you remember stuff from last week. What's going to be my reason that this thing is congruent to itself? Okay. Hint, knowing this is a huge flex. If you guessed the reflexive property, you are correct. I told you we needed to remember that. Now's the time to use it. So the reflexive property is a property in math that says a segment can be congruent to itself. So we use that reflexive property. Now have we proven that, have we gotten enough evidence, enough statements and reasons to say that these 2 triangles have to be the same? The answer is yes. So my very last statement, by the way, your very last statement is always what you're trying to prove. Your very last statement here is that triangle ACB is congruent to triangle ACD. Now again, we need a reason. We have to have a solid reason why we know for sure that these 2 triangles are congruent. So again, we want to think to our 5 postulates. Which of the 5 postulates were we able to prove? Well, we were able to prove that these 2 triangles are congruent by, what's your guess? If you guessed SSS, you are correct. And there we have it. That's our very first two-column proof. Okay. You can pause the video here to get those notes finished up, and then I'm going to move on to example 2. Okay, here's example 2. Again, you can pause the video quick here to sketch this triangle, write down your given, write down what I'm asking you to prove. This time I abbreviated statements and reasons, just S and R, but that's what the S and the R stand for. All right, let's go through this proof a little bit faster. Again, I see some given information here. And this time I'm asked to prove that triangle PUM is congruent to triangle SAM. So again, I'm trying to prove that these two triangles are congruent to each other. So I'm going to go after one of my 5 postulates. So let's start with step 1. Take a guess what your statement 1 will be. It should be that segment UM is congruent to segment MA. Our reason, again, hopefully by now this is making sense. Our reason that those two segments are congruent, well, that was given to us. And I'm going to mark UM and MA. My picture's kind of small, but I go ahead and mark it in there. Next, I'm going to mark the next statement will be that segment PM is congruent to segment SM. Once again, I know that's true because it's given to me. Given is like a free space in bingo. Here's PM, here's SM. By the way, this step of annotating your picture is really important because it's going to help you know which postulate we can use to prove triangles congruent. Okay, once again, I'm out of givens, right? And all I have is SS, which is not enough to prove the two triangles congruent. What I want to do next is figure out, hey, what's something else I know from geometry class that can help me either prove another pair of sides are congruent, like a reflexive property, or maybe another pair of angles are congruent. Well, in this one, hopefully you can see right in the middle there, we have two lines that cross each other creating vertical angles, right? So I'm going to get a pair of angles congruent here. This angle and this angle. Now, sometimes students call this angle M congruent to angle M. But again, we want this proof to be super duper clear. Angle M congruent to angle M is a little confusing because there's multiple angle M's in this picture. So I'm going to name them every time. I'm going to do this every time I have vertical angles. I'm always going to name them with 3 letters. So let's name that angle on the left side. I'm going to call it angle PMU. Is going to be congruent to the angle M that's on the right side there. So that's going to be angle SMA. That angle's a little kind of ran together with the S, but that's an angle symbol there. But I have to have a reason for knowing why those two angles are congruent. Well, I know that those have to be congruent because I know they're vertical angles, and vertical angles are always congruent. So that's my reason. Vertical angles are congruent. So I had my first 2 steps were given statements. My third step, I got a pair of angles here from the vertical angles. What I see now is, are these 2 triangles congruent? Yes, they are. Because what I see is I have 2 pairs of sides with a pair of angles in between. Now, when I look at my picture, if I've been annotating my picture, it's really easy to see that this is an SAS proof. If I haven't annotated my picture, it can be a little bit harder, which is why we want to make sure we annotate every time. So I have reached enough to prove it. So step 4, triangle PUM I know it because that's what I'm trying to prove. Triangle PUM is congruent to triangle SAM. Shout out to Sam. What's my reason? How do I know for sure that these triangles really are congruent to each other? Well, because I reached the SAS postulate. Boom, we're done. Second proof done. Now, the third proof, I'm not going to solve. You guys are, okay? So here's this third proof. So you can pause the video here. What I want you to do is I want you to draw out this proof. Look at the given information. Look at what I'm asking you to prove. And I want you to solve this proof entirely on your own. Try it. I don't care if you mess it up or have a mistake in there. Just try it. Think. See if you can do it. See if you can do a proof all by yourself. Okay? We are going to stop there. And again, make sure you submit this by 3 p.m. today on Canvas. And I hope you guys have a great day and stay safe. And I hope everybody's families are doing well. Take care. Bye.